morning, everyone. This is Shweta Singh, and I welcome all of you to Q&A session. So, how are you doing, Hannah and Samagna? Have you revised whatever we did in the last session? Am I audible? Samagna and Hannah, am I audible to you?
Yes, ma'am.
Okay, so I was asking, have you revised whatever we did in chemistry in last week? Okay, Samagna, you gave answer yes for what? Am I audible for that or you have revised? Hello, Kevin. How are you doing? Okay, so I believe all of you have revised. If not, let's have a recap. Good, Kevin. So have you revised, Kevin? Okay, Samagna has revised, but not fully, but little bit. Okay. Why is it so, Kevin? This revision session is already going on. We want you to score full on full when once, yeah, the school will start and you'll have the test. We want you to score full on full for that very important revision part. Okay, fine. So, what we did in the last session, let's have a look and then we'll move forward. Okay, so we actually discussed about the characteristics of particles of matter, isn't it? So what were the characteristics? Samagna, any one point can you say? Can you tell me any one of the point characteristic of the particles of matter? You can unmute yourself. You don't have to write, Samagna. I'll ask you, Kevin. Your turn will also come. Samagna, you can unmute yourself. Any one property of particles of matter. Okay, so you keep writing, Samagna. I'll ask Hannah now. Yes, Hannah, can you answer this question? Tell me any one
Ma'am,
characteristic. Hmm?
the particles of matter have spaces between them.
Very good. They have interparticle spaces. Okay, Kevin, and next one. So first one was they have interparticle spaces between them. Second one, Kevin. Okay, no issue, Samagna. That's why revision is important. Yes, Kevin, another point. The first one, they have interparticle space. Yes, Kevin, that's what. Oh, okay, you are telling me they cover space. So that's why that's the property of matter. And now we are talking about the particles. When we say what is matter, something that occupies space and has mass. Now, why is it occupying space? Because it is made up of particles. Why does it has mass? Because it is made up of particles. Now you need to tell me what are the characteristic of those particles. The first one, they have interparticle space. Second one, Samagna, now do you remember any other point? Okay, guys, let's write down. They react with each other. No, no. That's not true always that they will react with each other. Let's write down. Let's write down. Okay, so we are actually discussing the characteristics of particles of matter, right? So the first characteristic. Wait a second. What is happening? Yeah. So the first characteristic is Okay. Just give me a second. There's some problem with the pen. Yeah. So the first characteristic, they have interparticle space. They have interparticle space. Then what is the second characteristic? They have interparticle forces of attraction, right? And which one was the third one? They are continuously moving, means they have kinetic energy, right? They have kinetic energy. And one more point you can add, the particles are very small. They are very tiny particles. Okay, now tell me, for interparticle space, which activity we did for this interparticle space to prove that the the matter has got particles and the particles have interparticle spaces between them. Which activity we performed for that?
Ma'am, is it
Mixing sugar in water. Yeah, exactly, where the level of the water didn't rise. Very good. Yes, you can say Sanjeev came in a 4 also, no issue. Now for the interparticle forces of attraction, which activity was that? Which activity for interparticle forces of attraction? Do you remember? Chalk, iron nail, and ice cubes. We actually hit them with hammer. Do you remember? Yes, Hannah. And the third one, the particles are continuously moving. For this, which activity we performed? The particles have kinetic energy or the particles are continuously moving. Which
ma'am,
activity?
mixing ink in water?
Okay, mixing ink in water or potassium permanganate without stirring it, right? We didn't stir it with glass rod. Very good. Okay, so these are the three characteristics of particles of matter. Now, don't forget this. Okay, Samagna, Kevin, Hannah, have you understood? So this is very common question which is asked in exam. Okay, now coming to the next one. The next property what we need to discuss here, sorry, the next thing we discussed in the last session was about diffusion. What is diffusion? Intermixing of different particles on their own, right? So intermixing of particles on their own is called diffusion. And in case of diffusion, we saw the rate of diffusion that changes with temperature, isn't it? So we discussed that if we increase the temperature, the rate of diffusion increases. Why is it so? Because the kinetic energy of particles increase. Fine. The second thing we discussed, with increase in viscosity, of the liquid, what happened? The rate of diffusion increases or decreases? With increase in viscosity, the rate of diffusion. Come on, guys. We actually did this activity actually in the last session. So this is what happens when we don't revise. So rate of diffusion decreases with increase in viscosity. Understood? Is it clear now? Kevin? Okay, fine. One thing more I told you about the Graham's law of diffusion. Do you remember what was Graham's law of diffusion? The rate of diffusion is inversely proportional to the square root of density of the gas, right? So I told you to remember this thing. This is out of syllabus, but you should know. Okay, so Kevin, I just said how does rate of diffusion change with viscosity? So I said that with increase in viscosity, rate of diffusion decreases. Okay, so these are the things what we discussed in the last session. But for today's topic, we should know these three terms. First is viscosity, second is compressibility, and third is fluidity. So what do you understand by viscosity? We actually discussed in the last session how easily a fluid can flow actually, right? So basically viscosity is the resistance. Viscosity is the resistance caused by the intermolecular or interparticle forces of attraction to flow. So that resistance is is caused in the flowing. And why is it so? Because the particles, the like the when something flows, no, I'll show you here. Yeah, when something flows, it flows in the form of layer, right? So there are different layers of the particles of liquid. So what happens? There will be forces of attraction between the particles of different layers. So I can show it with different color here. So like the particle here has the intermolecular forces of attraction with the particles in the other layer. So what will happen when they will try to flow? In during flowing, what will happen? One layer will slide over the other layer. So there will be resistance. There will be internal friction, right? So that causes resistance in the flowing, and this resistance is nothing but the viscosity. Samagna, have you understood? I actually told you entire theory behind this. Okay. Now, compressibility. What is compressibility? That is the ability of a substance to be accommodated in lesser volume. Like, suppose I have a container, right? I have a container and I have a gas filled in it. Fine. Now, if I apply pressure on it, so what happens? This container, whatever the piston was there, it moves down. When it moves down, the gas will be accommodated only in this much of the volume, right? The gas will be accommodated only in this much of the volume. So this is compressibility, the ability of a substance to be accommodated in less volume. Suppose if I take sugar in it, right? If I take sugar in it and it is completely filled, right? And now I apply extra pressure on it and I try to push it down to decrease its volume. Will it be possible? Will it be possible? Can I accommodate the sugar crystals in lesser volume in this container? Tell me. No, definitely. See, the thing is, you have the container in your home, right? And you have sugar filled up till mouth, right? And now you are trying to push the sugar down so that it can be accommodated in this much of the volume only. Is it possible? No, it won't be possible. So it means it is incompressible, right? It is incompressible. But if I have a gas, I can accommodate in lesser volume. So it means that gas has got compressibility. Have you understood? Kevin, Sanjeev, Shaktivel, have you understood? Samagna, right? What is compressibility? The tendency of a substance to be accommodated in lesser volume. Okay, now what is fluidity? Tendency to flow. What is fluidity? Tendency to flow. Okay, so I hope all these terms are clear to you, and I hope you have written also. You have written also. You should know because you will get questions in your exam based on these properties. Okay, so these were the prerequisite for the topic of the day, and today the topic is states of matter. States of matter. We are going to see different states of matter, and it carries 1 to 3 marks. Okay, so in your exam, this the question which can come from states of matter, minimum 1 mark and maximum 3 marks. So in this session, we are going to see different states of matter and we will compare their properties also. Fine. Okay. But before that, there's an activity. Before that, there's an activity, and on the basis of this activity, you will find question in your NCERT exemplar also. Okay. So I believe you solved questions from your NCERT exemplar also. Okay, anyway, now in this activity, you have a glass jar in which red, brown, basically bromine vapors are present. Okay, in this, you have bromine vapors, and bromine vapors are reddish brown in color, as you can see here. Now I'm going to take another beaker. Okay, and this beaker is empty. Basically, it has got air only. Okay, it has got air only, so it is, we say empty or it is filled with air, whatever. Okay, now I'm going to put it inverted over the bromine jar. Okay, something like this. Fine. And I'm going to remove the separation between them. Whatever thing is separating them, I'm going to remove it so that there will be a connection between the two jars. Okay. Now, what am I going to observe? Can you tell me? What will be the observation? What do you think? If I keep this jar over it and there's no separation between them, like if you take two glasses, right? Two glasses and put them one over the other. What do you observe here? Anyone? Huh, you can say. You don't have to write. It takes time. You can say. Nothing will happen. There won't be any observation. So how do you come to know that, okay, mixing has occurred? That's definitely there will be mixing, but how do you come to know? What will be the observation? What are you going to observe here? You people love writing answer, but not speaking it, huh? Okay, no, dilution means what? Addition of water into the solution. Okay, anyway, so what will be the observation? The observation, the brown color of the bromine will be spread in both the jars. Isn't it? Am I right or not? It will be spread in both the jars, right? Now, what is the reason behind it? What is the reason behind it? This was the question in your NCERT exemplar. The one reason could be that bromine vapors are lighter than air. That's why they moved upward, right? One reason could be that the bromine vapors are lighter than air, so it moved upward. Or other reason could be diffusion, that is simply intermixing of particles. What do you think? Reason one or reason two, which would be correct? What do you say? Okay, so very good, Kevin, Sanjeev, Samagna. So Henna, the answer will be reason two. That is due to diffusion. Bromine vapors are heavier than water. Do remember this. That's why I'm saying that this is important, because the question is there in NCERT exemplar, right? So bromine vapors are heavier than air, but then also it moved upward. Why? Due to diffusion, that is intermixing of particles. And what are the two substances in which intermixing occurred? Bromine vapors and air. Okay, fine. Coming to the next one. So we understood what is there. The upper gas jar, which contains colorless air in it, also turns red brown in color. And this mixture is due to the diffusion of bromine vapor into air. Fine. So this is something I wanted to tell you before starting the, states of matter. Okay, coming to the states of matter now. Now, when we say states of matter, the states of matter is decided on the basis of characteristics of particles of matter. Right. So when we say characteristics of particles of matter, we actually talked about three characteristics there. What were those characteristics? The first one, interparticle space. Okay. Second one, interparticle forces of attraction. And third, kinetic energy, because they are continuously moving, so they have kinetic energy. So on this basis, we actually decided the states of matter. Now here comes three states of matter: solid, liquid, and gas. So what do you think, in which state interparticle space is maximum? Interparticle space is maximum in solid, liquid, or gas? Yes, tell me. Gas. Okay, so that's the right answer here. The gas has maximum interparticle space, and solid has the minimum, right? Least space is present in between the particles of solid. Okay, interparticle forces of attraction are strongest in solid, liquid, or gas? Exactly. They are strongest in case of solid, and weakest exactly in case of gas. Now coming to the kinetic energy. Kinetic energy is highest in case of solid, liquid, or gas? Exactly. In case of gas, the kinetic energy of the particles are highest in case of gas, and it is lowest in case of solid. Right. And when we talk about the liquid, it's moderate, means in between of each of them. Okay. Moderate. That whatever properties that will be in between solid and gas. So do remember, so on this basis, when the space between the particles are large and the forces of attraction very weak and kinetic energy of particles are very high, then we say that that state of matter is gas. Right. When interparticle space between the particles are least, they are compactly packed, then forces of attraction between them are very strong, and kinetic energy of the particles are basically very low. Right. So we say that that state of matter is solid. And whenever these properties are in moderate condition, we say it is liquid state. Am I clear? Am I clear? So on this basis, on the basis of these three properties, we decide the state of matter. So first state of matter, what we are going to discuss here, that is solid. Okay. So I'm going to erase it now. So we say three states of matter: solid, liquid, and gas. But we have two other states also that we will be discussing separately. Okay. So one is the plasma and other is the Bose-Einstein condensate. So little bit of knowledge should be there about the these two states of matter also, the fourth state of matter, that is plasma, and the fifth state of matter, that is Bose-Einstein condensate. So today we will just focus on the three states of matter: solid, liquid, and gas. Okay. So first, coming to the solid. As we said, in case of solid, the particles are compactly packed. They have hardly any space between them. So the space between the particles, that is least. Second, the forces of attraction between the particles, that is maximum, right? And then when we talk about kinetic energy, that is least between the in the particles. Okay, that is least, because forces of attractions are very strong. They are not allowing them to move. Fine. So they are compactly packed, they cannot move much. So on this basis, what are different properties of solid? First of all, they have definite shape and volume. So do remember, in case of solid, they have definite shape and they have definite volume. This is something you read in the junior classes also, right? So you can take any example. So that substance, like here we have book and pen, they have got their particular shape and the volume. Even the Almira is one of the example here, right? Next one, they are incompressible, right? These solids are almost incompressible. But here comes the question: what is the state of sponge? What is the state of sponge? Is it solid, liquid, or gas? Yeah, tell me. Solid, right? Sponge is solid. But is it compressible or not? Is it compressible or not? Yes, it is compressible. But here we mentioned they are incompressible. So how are you going to justify this? How are you going to justify that sponge is solid, but then also it is compressible? Okay, so one point I got, Sanjeev has said they are, sponge is porous, and Shubhranshu has said they have a lot of holes, okay, which allows air to escape. Okay, so let's put up like this. Exactly, that answer is correct. So basically, sponge is porous in nature. It has very tiny pores, which are filled with air. So when we compress it, what happens? The air escape out of the pores, and we see that the sponge gets compressed. Am I clear? So what are the key words here? First, you have to mention, right here, what are the keywords? First, you need to mention that sponge has very tiny pores. Fine. First, you need to mention a very tiny, many pores are present there, which are filled with air, right? Filled with air. And when we press it, then what happens? Air escapes out and the sponge gets compressed. See, pores, when we say pores, no, Kevin, so they are very small actually. They are very small things. So holes can be anything, right? So holes can be in the mud or can be in the soil, anything. But when we say pores, they are very tiny spaces. Understood? Okay, so this is one of the important question for your exam. I'm going to ask you after completing the solid part. I'm going to ask you people what, like, how can we say that sponge is compressible? Okay, so here we got one example that I have a stick, and if I try to compress it, it won't be, right? So there is no compressibility. So their volume does not change by any outside force. This is what we already discussed in prerequisite, what is compressibility. Now coming to the second one, solids are rigid. What do we mean by rigid? So if we try to change the shape of a solid, right, if by external force, it will resist, means the resistance, right? So what is rigidity? That is the inflexibility to resist the change in the shape, right? What is rigidity? The property to resist the change in the shape by applying, when we apply any force. So you can take any of these examples, they all are rigid. So when we say rigid, it means their shape does not change by any external force. When I'm saying these small terms, no rigidity, compressibility, the question can be asked to you, define compressibility, define rigidity for 1 mark. So you should know. I'll tell you, Samagna, I'll come to the clay also. Okay, but some solids are elastic. When we say elastic, means their shape changes on applying the force, but they regain their shape, right? So they change their shape, but when they change their shape when force is applied, but regain their shape once the force is removed. That is elasticity. And very good example, we have rubber band, right? We have rubber band. So do remember what is elasticity. That is the property to change the shape on application of the force, but to regain the shape once again once the force is removed. Okay, so the example we saw, that is rubber band. Now, the next one, some solids are plastic in nature. When I say plastic in nature, they change their shape when force is applied, but does not regain their shape when force is removed. And here, Samagna, the clay and dough are the example, right? Clay and dough are the example that if the force is applied on them, their shape changes, but when we remove the force, they do not regain their shape. Am I clear? Okay, so these are some properties of solid. So once again, what are different properties of solid? Solids have definite shape and volume. They are incompressible. They are rigid. Uh, and some are elastic and some are plastic. And you should remember their examples also. Okay, so now if I ask you what is compressibility, can someone answer me this question? What is compressibility? What is compressibility? How will you define it? Anyone? As I said, the question could be asked in your exam. 1 mark question. Okay, so let me define it once again. Compressibility. Yes, Sanjeev. Sanjeev wants to answer. You can unmute yourself, Sanjeev. The ability of a substance to be accommodated in less volume. Okay, to be accommodated in less volume, that tendency of a substance is called compressibility. But solids are incompressible. What is rigidity? What is rigidity? I'll give you one example. I have a pen. If I apply force on it, it is not changing its shape. It's rigid. So how will you define rigidity? Yes, Hannah. Come on, you can unmute yourself. Yes, Shubhranshu, you're right. But exactly if somebody, if it comes in your exam, how are you going to define it? The tendency of a substance to resist the change in shape when force is applied on it. The shape cannot be, yes, Hannah, the shape cannot be changed by external forces. So that tendency of a substance to resist the change in shape, right? That is rigidity. And I told you elasticity, that the shape will be changed on applying the force, but it will regain, right? The shape will be regained once the force is removed. Plasticity, the when force is applied, the shape is changed, but when force is removed, the shape does not regain its shape. That is plasticity. Okay, so this is what we had to do in this session. We discussed about the solid state, right? So I'll leave here only, but now what you have to do, I think you got the login IDs now, or you'll be getting today. So now today you'll be going to the class 9th foundation dashboard. Here on the platform, you'll click on the assessment. On this assessment, you'll go to the science section. In science, look for the topic. What is your chapter? Matter in our surrounding, right? So this is matter in our surrounding. You'll view topics. In topics, you get understand matter, demonstrate that matter is made up of tiny particles, demonstrate that particles have spaces between them. See, all of these topics we have done. If you want to do it, you are most welcome. But what do we you need to practice today? Describe physical properties of solid, right? Describe physical properties of solid. This is something you can practice for 30 minutes. Okay, fine. So this is all for today. Don't forget to join tomorrow also. We will continue this topic. We have to discuss liquid and gas. I already summarized it. We already had a recap of it. What are the different properties of solid state? Okay. Thank you, everyone. Don't forget to practice now. Okay. And this time, please come up with the revision. Today, nobody has revised. Okay. Don't forget to revise. Will you revise? Tell me. Are you going to revise? Yes, very good, Samagna. So I want everyone to revise and then come to the next session. And I'm going to ask you again the same questions. What is compressibility, rigidity, fluidity, and what are different properties of solid state? Okay. And do not forget to attempt questions on platform. Thank you, everyone. Take care.